Hello friends, welcome to Machine Learning the Future course. So in the last part we have seen the theoretical concept which is behind the SVM, and now let's begin the machine learning using Python. So I have already launched Anaconda. Let's copy this entire template and paste it in a new Python file. Let's name it as our SVM classification, or you can just say it as SVM support vector machine. And this is a very simple machine learning model creation where we just need to change our fitting model to training set template, and that will be it. So the everything will remain same. Let me first reset this. Set the namespace. Yes, we'll set the working directory. So the working directory will be set to SVM. Yes, so it will be SVM. The action of the name of the data set is exactly the same. Data set will be the same. Splitting of the training set data set will remain same. This entire section will remain same. Only this section will change. So fitting SVM to a training set involves which is known as SVM, and let's import a class which is known as SVC. So this will be changing to SVC, and the arguments inside this will actually change to kernel equals linear and random state equals 0. So that will be the arguments. If you want to look into the arguments, you can actually press Ctrl and I to actually look at the entire arguments. As you can see, SVC, wherein the most important arguments will be kernel. RBF is the default value, but we can actually have a look at the other values as well in the help section. So yes, so here if you want to look into some other values, so kernel default is RBF. It must be one of the linear, poly, RBF, sigmoid, or a global. So if none is given, RBF will be used, but we'll be using a linear case over here. And the last step involves fitting. So yes, that will remain same. This will exactly be the same. This will be the same. And if we want to change something in this, we can actually change this to SVM. And for the test set, similarly we'll change it to SVM, and that's it. So now we can actually execute this set of instructions one by one. So we'll actually execute this entirely. We'll remove this print statements because it will actually print that on the dashboard. So let's execute this till the confusion matrix, and yes. So confusion matrix states that there will be 10 results which are incorrect predictions, and there will be around 90 which will be the correct predictions. So let's look at our graph which will be plotted. So this will be the graph. Control enter, and yes, so that's the graph over here. So red region is the region where people has not purchased a new car, and the green is the people purchased a new car. So in this classification, kind of, you can say, machine learning model, we are actually just predicting this decision boundary and this region area, because all these points which are plotted are those points which are actually there. So this is the real value of those points which are present in our data set. but what we are actually doing in a machine learning model is classifying. So classification with respect to this red region and green region and the decision boundary is done by this machine learning model of classification. So that is what differs this from regression. In the regression part, we actually predicted the outcome, which is actually a kind of real number or salary or age of a person, but here we are actually just classifying that, so that any new point, if it comes here, it is automatically in the red region, and if the new point comes here in the green region, it is the region where the person has purchased a car. So that's what it is. So here is the actual predictions with respect to our test set, and if you can actually count, there will be 10 values as confirmed by our confusion matrix, which will be an incorrect predictions. So that's it. All those steps and datasets will be available at my GitHub account. So hope you're enjoying this video series. Thank you very much. Bye bye.